I think many would agree with me when I say probabilities are one of, if not the most confusing aspect for humans to grasp. This picture has been going viral online and it's a complicated variation of the boy or girl paradox. So to recap the puzzle, a family has two children, and one of them is a boy born on a Tuesday, and yes, the day is relevant to this puzzle. The question is, what's the probability of the other child being a girl? This picture first assumes it is 66.66%. The logic behind it is if it's two children, there are four possible outcomes. Either they are both boys or both girls, that's two. Or the first one is a boy and the second is a girl, or vice versa. These two are the same, but the order is different. And because they told us one of them is a boy, that eliminates the two girls possibility. So three possibilities remain, meaning it's 66.66%. Some would like to say it's 50% because boy girl or girl boy is not a big difference, and even the guy who came up with the original puzzle acknowledged that this question was ambiguous and that the answer depended on how the wording was put, but that's not our topic. The important thing here is that 66.66 and 50% are both wrong answers when it comes to this variation presented to us today. Probabilities can drastically change depending on the wording of the same question. Remember I told you earlier the boy was born on a Tuesday, and that changes everything because we need to consider all possible combinations of two children where at least one of them is a boy born on a Tuesday. Normally each child could be a boy or girl born on one of 7 days, so that's 2 genders times 7 days equals 14 possibilities for each child. The total number of possibilities for a family with 2 children is 14 times 14, which is 196, but we need to count only the families where at least one child is a boy born on Tuesday. This gives us 27 valid combinations that meet our criteria. Here's how. If the first child is a Tuesday boy, the second can be any of the 14 possibilities. If the first child is anything else, meaning 13 possibilities, then the second must be a boy born on Tuesday. That's 14 plus 13 equals 27 total cases. Among these 27 cases, how many have the other child as a girl? If the first child is a Tuesday boy, the second child has to be a girl born on any of the 7 days. That's 7 cases. But if the second child is a Tuesday boy, the first child has to be a girl born on any of the 7 days. That's another 7 cases. So we have 14 cases where the other child is a girl. Therefore, 14 out of 27 cases have the other child as a girl, which equals 0.518 or approximately 51.8%. Unlike the Monty Hall or birthday paradox, I think this one is way simpler, but it complicates itself by including the days of the week and having an ambiguous wording.